The T-34 was a medium tank. Its hull measured 20 feet long, extending to 26 feet 7 inches with the main gun at full forward position. The tank was 9 feet 10 inches wide and 8 feet 10 inches tall. Its combat-ready weight was approximately 70,500 pounds. The hull was divided into 4 compartments: the control compartment at the front, the fighting compartment in the middle, the engine compartment, and the transmission compartment at the rear. Its crew consisted of 5 men. The 2 hull crew members were seated in the control compartment. The driver sat on the left on a floor-mounted seat, adjustable to 3 heights. The seatback could fold flat, allowing him to crawl back into the fighting compartment if needed. The machine gunner sat to the driver's right on an identical adjustable seat. He operated the hull-mounted DTM machine gun. The remaining 3 crew members were positioned in the turret above the fighting compartment. The gunner sat forward of the commander to the left of the main gun. The commander sat directly behind him at the rear left of the turret. The loader occupied the right side. The T-34 had no turret basket, and the crew did not stand on a rotating floor. The hull below the turret was completely open. The T-34 was armed with an 85mm Zis S-53 gun and 2 7.62mm machine guns. The 85mm gun was the defining feature of the tank. Almost every other design decision revolved around it. It had a barrel length of 15 feet and 3 inches and a caliber of 85mm. Most guns of this type had the recoil brake and recuperator mounted above the barrel. In the T-34-85, they were moved underneath instead. This lowered the gun's overall profile and reduced the distance between the breech and the rear turret wall. The breech used a vertical sliding block with a semi-automatic mechanism. This meant it opened and ejected the spent casings after each shot. The T-34 carried between 55 and 60 rounds. Most of the load consisted of high-explosive fragmentation shells. A typical loadout included 36 of these, alongside 14 armor-piercing rounds and just 5 sub-caliber rounds. The shells were adapted from the 85mm anti-aircraft gun, which simplified Soviet supply lines during the later stages of the war. The primary armor-piercing projectile was a pointed nose round, which lacked a ballistic cap. This made it easier to manufacture, but increased the risk of ricochet when striking sloped armor and impaired its aerodynamics at long ranges. It weighed 20.6 pounds and left the barrel at 2,625 feet per second. It could reliably penetrate 4 inches of armor at 1,094 yards. Like most Soviet armor-piercing rounds, it also contained a small explosive charge. The sub-caliber shell was built around a tungsten carbide core. It was lighter than the standard shell at 11 pounds and left the barrel at speeds of up to 4,000 feet per second. The sub-caliber shell had several components. An aluminium alloy ballistic cap at the tip reduced air resistance. Behind it, a lightweight steel body shaped like a spool had a 1.4-pound tungsten carbide core in place. A tracer was screwed into the base. The design stripped away as much weight as possible from everything except the core itself. This allowed the powder charge to accelerate the shell to nearly twice the muzzle velocity of a standard round. On impact, the steel body was crushed against the armor plate. The tungsten core carried the concentrated kinetic energy forward and punched through the armor. At 547 yards, it could penetrate between 5.4 and 5.5 inches of armor, enough to punch through the side plate of a King Tiger. Its effective range was limited to around 1,100 yards, and tungsten was scarce, so commanders kept these rounds in reserve for the most dangerous targets. Because the loader was not connected to the tank's internal intercom, communication was often physical. Tank commander Semyon Arya recalled, I would stick my fist under the loader's nose, and he would know that he had to load an armor-piercing shell, and if I held out my palm, he would know to load a fragmentation shell. The gun was fired electrically using a lever on the gunner's elevation handwheel. If that failed, a pull handle on the left side of the breech could be used as a mechanical backup. The gunner grabbed it and pulled down with his right hand. Firing the gun carried real risks for the loader. The breech recoiled between 11 and 12.6 inches, and a direct blow in that confined space could easily break an arm or even kill. To prevent this, the gun featured a safety button on its right side. The loader had to move clear and press the button before the gunner could fire. A long guard with shields was also fitted to the breech to help keep the crew out of the path of the recoil. The 85mm rounds required a much larger propellant charge, nearly 3 times the size of the charge used in the previous tank variation. That meant far more fumes inside the turret. 2 ventilation fans were positioned at the rear of the roof, but they struggled to clear the gases during sustained firing. The loader was the most exposed and could even lose consciousness during prolonged engagements. The fire rate was said to be 6 to 10 rounds per minute, though in practice, the actual combat rate was around 3 to 4. The gunner aimed using the TSH-16, a telescopic sight designed specifically for the 85mm gun. It had a fixed magnification of 4 times and a field view of 16 degrees with a maximum aiming range of up to 2.36 miles. The TSH-16 had 2 main parts. The front of the sight was fixed to the gun cradle and moved with the barrel. The eyepiece was attached separately to the turret roof and stayed in place. This meant the gunner's eye position stayed the same no matter how the gun moved. The sight featured several vertical range scales on a glass plate, each corresponding to a different shell type. The gunner could set the range by rotating a handwheel. This moved the glass plate vertically until the correct range mark aligned with a fixed reference line. The reticle included a central chevron for stationary targets and additional lateral marks for moving ones. This gave the gunner a basic way to estimate range without a dedicated rangefinder. The T-34 was equipped with 2 7.62mm Degtyaryov modernized tank machine guns, or DTMs. The DTM was a tank-adapted version of the standard Degtyaryov infantry machine gun, fed from a drum magazine holding 63 rounds. The tank carried 30 of these magazines in total, giving a combined ammunition load of between 1,890 and 1,953 rounds. The first DTM was mounted in the turret, immediately to the right of the main gun. It was fixed to the gun cradle, so it pointed wherever the barrel pointed. The gunner fired the machine gun electrically using the same trigger lever on his elevation handwheel that he used for the 85mm. 2 toggle switches on top of the elevation mechanism let him select which weapon the circuit was connected to. The second DTM was mounted in a ball mount on the right side of the front hull plate, operated by the machine gunner seated to the right of the driver. Its field of fire was limited, approximately 12 degrees to the left and right, 16 degrees of elevation, and 6 degrees of depression. The machine gunner aimed through a PPU-8T telescopic sight with 2 times magnification. His view of the battlefield was severely restricted. A target was difficult to locate at all unless it was almost directly in front of the tank. If the tank encountered a position it could not overcome, the commander could trigger 2 tank-adapted naval MDSH smoke canisters mounted on the rear hull. They produced a dense white cloud within seconds. The cloud lasted up to 10 minutes, enough to mask withdrawal or cover the tanks following behind. The T-34 was designed to operate alongside infantry and exploit breakthroughs at speed. Its armor reflected that role. The hull was designed in such a way that it allowed it to be built fast and in enormous numbers. Soviet factories used automated submerged arc welding to join the plates, a far faster method than manual welding and requiring less skill, while also producing strong, more consistent seams. This mattered greatly because much of the workforce assembling these tanks consisted of teenagers and workers with little or no prior experience in heavy industry. The upper and lower front plates were both 1.77 inches thick, set at 30 degrees from horizontal. That angle increased their effective thickness to 3 inches. The upper plate housed the driver's hatch, the machine gun embrasure, and 2 towing hooks. The driver's hatch had 2 prismatic viewing devices, protected on the outside by hinged armored covers, which crews referred to as eyelashes. Each side of the hull was made from 2 plates welded together. The upper plate covering the sponsons was angled at 50 degrees from horizontal. The lower plate was vertical. Both were 1.77 inches thick, though the angle of the upper plate increased its effective thickness to approximately 2.32 inches. The rear of the hull consisted of an upper and lower sloped plate, along with 2 gearbox housings. The upper rear plate was hinged and bolted in place, so it could be removed for engine access. A large round hatch in the center of the rear upper plate provided access to the transmission compartment. The hull roof was 0.79 inches thick. The floor consisted of 2 plates joined by a welded seam. The front plate was 0.79 inches thick and the rear plate was thinner at 0.51 inches. A narrow escape hatch for the driver and machine gunner was located at the front of the floor. The T-34-85's turret was the main difference between this tank and its predecessor. Its turret expanded the internal volume by approximately 1.5 times more than the T-34-76, enough to fit a dedicated gunner inside for the first time. The ring diameter was increased to 63 inches to accommodate the larger gun. To prevent the turret from catching on the hull when rotating, it was mounted on a raised collar, a distinctive raised neck visible from the outside of the tank. This added 8.7 inches to the overall height of the tank, and unlike the older T-34-76, this tank was now an easier target to spot and to hit. The main body of the turret was cast as a single piece with only the roof welded on separately. Cast armor offered slightly lower ballistic resistance at the same thickness as the German armor, typically constructed from rolled plate. But it allowed complex curved shapes to be produced more quickly and with less skilled labor. The frontal shield was cast together with the turret body, removing the need for a weld at the most vulnerable point. The turret was rotated by an electric drive turning at 24 to 26 degrees per second. A full rotation took between 14 and 15 seconds. Unlike the hydraulic systems used in many German tanks, the electric drive was independent from engine speed. The turret traverse mechanism was controlled by a single lever that switched between electric and manual operation. In the vertical position, it engaged the electric motor for rapid turret rotation. When moved to the horizontal position, it enabled precise manual aiming. On the outside, 2 ventilation fans were fitted at the rear of the turret roof, covered by armored housings that crews referred to as mushrooms. The commander's cupola was positioned on the rear left side of the turret roof, directly above this station. The main gun ammunition was distributed across 4 locations. 4 shells were stored on the right wall of the turret in a quick-access clamp rack. Another 12 to 16 were kept on a shelf in the turret bustle directly behind the loader. These were the most accessible rounds in the turret. The remaining 39 to 40 rounds were stored in the hull. 35 were in 6 metal boxes bolted to the floor. The last 4 or 5 were secured upright, 2 directly behind the bow machine gunner, and the rest in the rear corners of the fighting compartment near the engine firewall. Retrieving rounds from the floor boxes was the most demanding part of the loader's work. As the turret rotated, he had to move with it or be knocked off his feet by the moving breech. He stepped on the ammunition boxes fixed to the hull floor, retrieved the next round, and cleared the breech path before each shot. Due to the cramped space, loaders were usually under 5'7" tall. 15 machine gun magazines were placed directly in front of the machine gunner for immediate use. 4 more were mounted on the right wall of the turret for the loader. The remaining magazines were stowed throughout the hull. The T-34 was powered by the V234, a 12-cylinder V-type diesel engine producing 500 horsepower at 1,800 RPM. It was the first mass-produced tank diesel engine in the world. The engine had originally been developed by a factory that built aircraft engines, and that heritage showed in its construction. The block and crankcase were cast from an aluminium-silicon alloy, keeping the dry weight down to around 1,650 pounds. The total displacement was nearly 39 litres. Because the engine ran at low RPM, it needed large cylinders to generate enough torque to move the tank. The bore measured 5.9 inches and the stroke 7.4 inches. The low RPM and high compression ratio made the engine fuel efficient, giving the tank a road range of around 186 miles. That was critical to its role as a breakthrough tank. The engine featured a dual starting system. The primary method used a 15 horsepower electric starter. If batteries failed or temperatures dropped too low, the driver could start the engine using compressed air fed from 2 cylinders at his feet. The tank had a top speed of 34.2 miles an hour on a clear road, just a few miles an hour short of a fully loaded classic London double-decker bus. Although operational speed was typically lower across rough terrain. On the battlefield, speed and maneuverability became the T-34's primary defense as it lost its armor advantage. Tank driver Nikolai Zheleznov recalled, "The tank charges at high speed, zigzagging and constantly changing direction. If it heads straight ahead, you might as well say it's headed for the afterlife." The T-34 carried its fuel in 8 internal tanks with a combined capacity of 144 gallons. These were divided into 3 specific groups. The left and right side groups each consisted of 3 fuel tanks, 2 in the fighting compartment and 1 in the engine compartment, holding 52.8 gallons per side. The remaining 2 fuel tanks made up the stern group, located in the rear transmission compartment, which held a combined 38.3 gallons. The internal side fuel tanks presented a serious risk. 2 of them sat inside the fighting compartment alongside the crew. A penetrating hit through the side armor could pierce them directly. But because the T-34 ran on diesel rather than gasoline, the liquid fuel itself was difficult to ignite. A hit to the full fuel tank would shower the crew in diesel, but it rarely caught fire. An empty fuel tank, however, was a different matter. The vapor that accumulated inside it could detonate with the force of a high explosive shell. Most crews went into battle with full fuel tanks, accepting the extra weight. A full fuel tank left less space for vapor to build. 3 additional cylindrical drums were carried on the outside of the hull, each holding 23.8 gallons. These external tanks were not connected directly to the engine. They were used to refill the internal tanks during stops. The T-34 had a road range of approximately 186 miles on internal fuel tanks alone. Fuel consumption varied between 0.5 and 0.7 gallons per kilometre, depending on the terrain and load. The cooling system consisted of 2 separate circuits, one for the water and one for the oil. The water circuit held 19.8 gallons. It was sealed, and internal pressure raised the boiling point of the coolant to around 230 degrees Fahrenheit. The driver monitored coolant temperature through a remote thermometer, with normal operating temperature reaching up to 221 degrees Fahrenheit. A large centrifugal fan was mounted directly on the engine flywheel, bolted to the crankshaft. It ran whenever the engine was running and drew in air through armoured shutters on the engine deck, pulled it across the radiators and expelled it through the shutters at the rear of the hull. The oil circuit ran alongside the water system. A tubular oil radiator was mounted onto the left water radiator. Oil thickened in cold weather, and the pressure it generated was enough to burst the core. During winter, the oil radiator was replaced with a straight pipe. The driver controlled the tank using 2 vertical steering levers, one on each side of his seat, along with 3 foot pedals and a gear lever to his right. The steering levers operated the side clutches and brakes for each track. Pulling a lever halfway disengaged the clutch on that side and produced a wide turn. Pulling it fully applied the brake, tightening the turn. Early versions required significant physical effort, up to 132 pounds of force per lever. Later models introduced a spring-assisted servo mechanism that reduced this to around 44 to 55 pounds. The 3 pedals followed a similar layout to a manual car. The left pedal operated the clutch, disconnecting the engine from the transmission for gear changes. The center pedal controlled the transmission brakes, and the right pedal was the accelerator connected directly to the fuel pump. The gear lever operated a 5-speed gearbox. The transmission was mounted at the rear of the hull. The lever connected the gearbox through a long mechanical linkage that ran under the floor. Changing gears required considerable force if the linkage was not kept in precise adjustment. The machine gunner seated next to the driver was sometimes called on to help with a particularly difficult gear shift. A hand throttle allowed the driver to hold a steady engine speed without keeping his foot on the accelerator. The V2-34 could be started in 2 ways. The primary method used an ST700 electric starter producing 15 horsepower. Before engaging it, the driver turned on the battery master switch, confirmed the gear lever was in neutral, and selected which group of fuel tanks would feed the engine. The fuel and lubrication systems then had to be primed manually. The driver pressurized the fuel tanks using a hand air pump near his feet. He waited until pure fuel appeared before closing the drain valve. He then ran a mechanical oil pump to circulate oil through the engine block before ignition. Skipping any of those steps risked a dry start, which caused rapid wear to the internal components. Once the systems were primed, the driver depressed the foot throttle slightly and pressed the starter button. The starter could not be held for more than 4 to 5 seconds at a time. The driver had to wait 10 to 15 seconds between attempts to avoid overheating the motor or draining the batteries. The crew switched to compressed air backup if the batteries were dead or if the temperature was too low for the electric starter. The driver opened the valves on the 2 cylinders in front of his feet, depressed the clutch and fuel pedals, and then turned a reductor valve to send high-pressure air directly into the cylinders in the correct firing sequence. The air forced the pistons down and rotated the crankshaft until the engine caught. Once the engine fired, the valves had to be closed immediately. The engine had to warm up before the tank could move. The driver closed the radiator shutters and ran the engine at 700 to 800 RPM until the oil reached 50 degrees Fahrenheit, then increased to 1200 to 1600 RPM until it reached 86 degrees Fahrenheit. The tank was not ready for movement in higher gears until both oil and coolant temperatures reached at least 113 degrees Fahrenheit. The T-34 used a 5-speed gearbox. This was an upgrade over the 4-speed unit fitted to earlier models, which had been one of the most criticized components of the original design. The new gearbox used constant mesh gears with sliding tooth clutches, which made shifting easier and reduced mechanical stress on the drivetrain. The rear-mounted layout kept the drivetrain compact. Power started at the engine and passed through a dry, multi-plate clutch on the flywheel. From there, it moved through the gearbox, then onto a pair of side clutches and strap brakes that controlled steering. Finally, it reached the rear drive sprockets through single-stage reduction final drives. The transmission remained a known weak point despite the improvements. The gearbox was prone to wear under hard use. Soviet engineers addressed this with a practical solution: a hinged rear plate and removable engine roof allowed mobile maintenance units to swap out entire engines and gearboxes without sending the vehicle to the rear. A tank that could be returned to the fight quickly was worth more than a technically superior vehicle that could not. The T-34 used a Christie-type suspension system, inherited from the earlier BT Soviet tank series. Each side had 5 road wheels. Each of the 5 road wheels operated independently, connected to large cylindrical coil springs housed inside armoured shafts within the hull. The springs were protected, but they ran through the interior of the fighting and engine compartments, taking up precious space inside. The front springs were mounted vertically, with one spring nested inside another, to absorb the impact of obstacles. Each track was 19.7 inches wide and made up of 72 links. The wide tracks kept ground pressure low and allowed the tank to cross terrain that heavier vehicles could not. The suspension had no hydraulic shock absorbers. This produced severe vibrations at high speed. Accurate fire on the move was extremely difficult, and crews experienced considerable fatigue during long journeys. Due to a severe shortage of rubber, the mid-war all-steel wheels on Soviet tanks generated a lot of noise. By 1944, increased synthetic rubber production allowed the T-34-85 to have rubber-tired wheels, which reduced both noise and crew fatigue. In a typical engagement during the summer of 1944, a platoon of 3 T-34-85s would be used to seize a road junction, ahead of a retreating German column. Each tank would carry 7 or 8 infantrymen riding on the hull. On rough dirt roads, a platoon of T-34s could move fast enough to beat the enemy to the position. Once in position, the commander would order the infantry to dismount and take cover. The commander's tank and a second tank would take concealed positions, ideally behind a low rise, while a third tank worked its way around the far side of the battlefield. When a German column entered the engagement area, the Soviet platoon would normally try to engage the armoured vehicles first. If the column was led by a Panzer IV and covered at the rear by a Stug 3, one T-34 would fire on the rear vehicle to limit the column's ability to withdraw or manoeuvre, while the commander's tank engaged the lead vehicle. At a range of around 500 meters, the 85mm gun of the T-34-85 was capable of penetrating the frontal armor of a late model Panzer IV. Knocking out the lead tank was crucial, as it could block the road for the rest of the column. After that, the Soviet fire would shift to the transport vehicles and infantry. High explosive shells from T-34-85s, combined with small arms fire from the dismounted infantry, would be used to suppress the German troops before they could deploy anti-tank weapons effectively. If the Stug 3 at the rear managed to use an embankment or cover in the ground to avoid direct fire, a third T-34 would usually engage it from the flank. Once the German armoured vehicles had been disabled, the rest of the column could be forced to stop or disperse. The T-34 was not the most powerful tank of the war. In a straight fight at long range, a Panther or a Tiger held a distinct advantage. But it was capable of operating where heavier vehicles could not. It was fast enough to maintain the pace of an offensive, and most importantly, it was easy and fast in production. Breaking down a machine like this in such detail means that there may be errors or omissions. If you spotted any, or if there's something you'd like us to cover in more detail, then please let us know in the comments. If you'd like to see more, take a look at our film on the King Tiger, a completely different approach to the idea of a World War II tank.